All right, guys, so this is a video for the 8.1 notes, which is our geometry review. So we're going to start with the special right triangle. So just a reminder, we got 2, 30, 60, 90, and then of course we got 45, 45, and a 90. All right, so for the first example, so just to review, from what we remember, that the short leg for the right triangle, it's always an x. Um, The hypotenuse, it's always going to be 2 times the length of an x. And right here, it's going to be x root 3. Okay? Um, so if I'm looking at my example number 1, 5 is my x, right? So my x is 5 here. Then I know that my hypotenuse, which is my y, right here, so just make sure you understand this is a right triangle, and this is your hypotenuse. This is going to be 2 times x, right? So if x is 5, this is going to be 2 times 5, which is 10, okay? So y is going to be 2 times x, which is 5. So y is going to be 10. And now a length x is x root 3. So since x is 5, that's going to be 5 root 3, okay? All right, example 2. Now my short leg is not given. What is given is and neither is my hypotenuse. What's given is this length right here, which is 15. So remember that this is x root 3. Okay. So what does that mean? That means that we are going to figure out what x is based on knowing the 15. So how do we do that? We are going to take x root 3 and equal it to number 15. So we know that this is normally x root 3. We also know that this length is given to us that it's 15. So figure out what x is, we got to equal them to each other. In that case, we're going to solve for x. So be able to do that, we do need to divide by root 3 to get rid of this. So now x will come down to be 15 over root 13, root 3. Now remember that we can't end with the root on the bottom. So to get rid of the square root on the bottom, we're going to multiply it by that root twice, top and the bottom. Now what that's going to do is it's going to get rid of the roots. So cancel out the root here. So what the bottom is going to end up being is just number 3. Because remember that it's square root of 3 times square root of 3, which is really square root of 3 twice, which really cancels out the 2 and a root to give it a 3. That's how we got the 3. The root multiplied by each other would cancel the root itself. And on the top, you're simply going to get 15 root 3. You just multiply 15 times 3. You do not combine anything. You can't combine normal numbers with the square roots. So, and then of course, can I simplify it further? Absolutely. Where I can simplify it is divide 15 by 3, and that's going to give me 5. So this can simplify to 5 root 3. So guess what? My x is 5 root 3. That's what I'm saying. So this side is x, so that means this side is 5 root 3. So that's what my x is. X is 5 root 3. Now, the hypotenuse side is 2 times x, okay? So again, we can calculate that by saying, okay, what is my x? 5 root 3, 2 times x equals 2 times 5 root 3 equals 10 root 3. So that means my hypotenuse side, y, right here, it is going to be 10 root 3, okay? So that's just a reminder how to do a 30, 60, and 90 angle. Again, that's a set formula. Hypotenuse is always 2 times the x, the value of x. The short leg, it's always the value of x. And then this length, it's always going to be x root 3. So you're basically just finding an x and then filling out the rest of the lengths, okay? All right, now 45, 45, and a 90. This is x and x, they both the same, because again, this is 90 degrees. And then the hypotenuse is always going to be x root 2, okay? So let's start with the first example. So if this is x and this is x, x equals 8 here, okay? So that means that this equals 8 as well because this has the same length, okay? Now the opposite, I mean the hypotenuse right here is 2, it's x root 2. So if I know that um, x is my 8, so that means it's 8 root 2, okay? This length right here. So all I'm doing is plugging in 8 for x, okay? And then example number 2 right here. The same thing. We got x, and we got x root 2. So now we don't know what the x's are, but we do know that x root 2, this hypotenuse equals 10. So I can take this and say x root 2 equals 10, right? Now, of course, to solve for x, we got to divide by a square root of 2 to get rid of it from the left side. So you're going to get 10 root 2. Now, to get rid of that square root underneath, that radical, we're going to multiply it by itself. So that will undo the radical. So this is going to be a 2. And then on the top, you are going to have 10 root 2. And of course, 10 does divide by 2 again. You do not touch the radical. The radical always stays the same. But 10 does divide it by 2, which is 5 root 2. So that's what my x is, which means that right here, both of these sides will be 5 root 2 and 5 root 2 because they are the same, okay? All right, now ratios. So just remember, this is just a little reminder that this is the longer, it's your hypotenuse. Adjacent, so this is your angle theta. This is adjacent. And this is opposite, obviously. Okay? All right. So I can probably copy that and move it here. It would be easier. Let me move it here so you have it with you, okay? Says find the missing side length of each triangle and the ratio of each indicated trig ratio, okay? So the first one we're starting is sine 30. So sine 30, that is again opposite over hypotenuse. So sine 30, it's opposite over hypotenuse. So that's going to be, so first of all, we have a 1 here, okay? So remember, this is 30, 60, and 90 angle, right? So this is my x, and this is 2x, and this is x root 3. So first we got to find what x is, okay? So since here, the things that are given to me is that the side of 2x, it's equal to 1, right? So now what is x? Of course, we just simply self to x. So we use this and we equal them to each other, right? So we divide by 2, x will equal 1/2. All right, so that means that this side right here, it's 1/2. Okay, now this side is 1, and then this side is going to be 1/2 root 3. So we're going to erase this, and we're just going to put in 1/2 instead of the x, okay? Root 3. Okay, so that really we could write it as root 3 over 2, the same thing. Okay, all right. Now sine 30, that is opposite over hypotenuse. So opposite, which is 1/2, over hypotenuse, which is 1. So that is just 1/2. So a sine 30, it's 1/2. Okay. All right. Next one. We're going to have cosine 30. So remember the cosine, it's adjacent over hypotenuse. So the one next to you, right? So adjacent is root 3 over 2 over 1. So once again, that's just root 3 over 2. Tangent. Remember the tangent is opposite over adjacent. Does not include the hypotenuse. So opposite, which is 1/2, over adjacent, which is root 3 over 2. Now, of course, you got to keep, change, flip. So let me move this. So let me start over here. So we have some space, okay? So again, it's opposite over adjacent. So you're going to do keep, change, and then flip. Okay, now 2 and 2's we cancel. So you're going to have 1 over root 3. And remember, to get rid of the radical on the bottom, you're going to multiply it by a root 3. So this root 3 times root 3 is just going to be a 3. It cancels out the radical. And on the top, you're going to have 1 time root 3, which is 3. So your final answer is root 3 over 3. Move it a little lower here. All right. So this was 1/2 root 3 over 2, and then 1, okay? So now sine 60. So sine, again, it is opposite over hypotenuse, okay? So 60 is right here, okay? Opposite is root 3 over 2. Over hypotenuse, it's 1. So it's 3 over 2. Cosine, okay, that's adjacent over hypotenuse. So 60 adjacent next to it, it's 1/2 over hypotenuse. So that's just 1/2. And then once again, tangent, it is, of course, a opposite over adjacent of 60. So opposite, it's going to be 1 root 3 over 2 over adjacent, which is the one next to it, which is 1/2. Okay, so that means it's keep, change, flip. So we're going to keep this one, we're going to change it, and we're going to flip it. And this is nicely going to cancel out to be a root 3 over 1, which is root 3. All right, and then we're going to move on to a sine of 45. So again, sine of 45, that is opposite over hypotenuse. But we first have to figure out what are our sides. So remember that this is x and this is x. Now, this is 2x, okay? I'm sorry. This is x root 2, okay? So that means we are going to take this and equal it to each other. X root 2 equals 1 to figure out what x is. And we're going to divide by a root 2. So x will equal 1 over root 2. Of course, we can't keep the root on the bottom. So we're going to multiply it by the bottom itself. This is going to cancel the radicals, which leaves it with 2. You do not multiply it to be a 4. You just drop the radicals. And then on the top, you're going to have a square root of 2. So that means that this side, it's square root of 2 over 2, and this side is square root of 2 over 2. And this is, of course, 1 right here. Okay, so now sine 45, that's opposite over hypotenuse, so that's square root of 2 over 1, which is square root of 2 over 2. Cosine is, of course, going to be adjacent over hypotenuse. So cosine of 45 adjacent, which is square root of 2 over 2 over 1. That's also going to be square root of 2 over 2. And then tangent is going to be our opposite over adjacent. So opposite, it's square root of 2 over 2 over square root of 2 over 2. And hopefully you will know that this is 1. Okay? All right. Now moving on to a radian measure. So degree to a radian is a radians to a degree. So you just multiply it by pi over 180 and 180 over pi. Degrees, right here, you got a 0, 0. For the double number line shows degree measurements on the line and the radians on another. Fill in the radian measures on the bottom line for the indicated degree measure. So here, 90, if I want to do it to a radians, I'm going to do 90 over 1 times pi over 180, right? How do I know which one to pick? If I pick pi over 180 or 180 over pi? The way I look at it is I want the number to be able to simplify diagonally, or pi's to be able to simplify diagonally. So in this case, I got numbers here. So I want to turn it into the pi. If I have a pi, I want to turn it into a number. So I'm going to multiply by pi over 180. And then, of course, 90 and 180 will cancel out. This is going to be 1 and this is going to be 2. So really, this is going to be pi over 2. So here we're going to get pi over 2. Then we're going to go 180 over 1 times pi over 180. So D is going to cancel out, so this is going to be a pi. 270 times pi over 180. So these are going to simplify. This is going to be a 3, and this is going to be a 2 if we divide it. And so you're going to have 3 pi over 2. And lastly, 360 over 180, that's going to be a 2 pi over 2 pi. Okay? So let's play around with it a little bit. So how do I know which one? Okay, radians, radians. So again, I have a pi here. So I have either 180 over pi or pi over 180. Well, if I have pi over 3, I want a pi on the bottom here. So that means 180 has to come on the top. Why? Because I want to get rid of the pi. I'm moving it from radians to a degree. I don't want a pi. Okay? So that means I am going to get rid of it. So it's going to be diagonally. Okay? Now 180 over 3, it's going to be 60 degrees. Here, the same thing. I got 5 pi over 4, so I'm going to multiply by a pi on the bottom, and then 180, okay, because I want the pi's to cancel. Pi, pi. So now you have 5 times 180 divided by 4, okay, and that is going to be 225 degrees, okay. Now, on the other hand, here, I got a number, so I need a pi, so 30, I want a 180 on the bottom to diagonally cancel out and pi on the top. So that's going to simplify to a 1 and a 6, okay? And so when you multiply it out, it will be pi over 6. And then lastly, we got 120 times, again, pi over 180. And again, you want them diagonally, so this is, it's going to be by 60 divided by 60. So 120 divided by 60 is 2. 180 divided by 60 is 3. So you're going to have 2 pi over 3. And that's it for this review lesson.